Well, this is the supplemental video for lesson 15. I want to work out a couple of more examples that will help us to see the process of implicit differentiation. For those folks that feel like they might want extra practice, just want to get a little bit more I'm sorry, this is example 3, who want to see the procedure a few more times. It's not a bad idea to want to do that. Find all points on x cubed plus y cubed equals 3xy, where the tangent is horizontal. And we know that there are probably points where the tangent is horizontal because we can graph this sucker and it looks something like this. So we imagine that there are two places where the tangent line is horizontal. One is here and one is here. In calculus language, if the tangent is horizontal, we're looking for the derivative to be 0. So we're looking for a derivative. We don't have one yet, so we'll run through the process of implicit differentiation. The derivative on the left side, the derivative of x cubed, is pretty straightforward. The derivative of y cubed is 3y squared if it's with respect to y, but it isn't, so we multiply by dy dx. And then the derivative on the right side is the derivative of a product. That's so much fun. That's first times derivative second plus second times derivative first. And then our process says we kick all the dy dx stuff to one side and factor. We kick the non-dy dx stuff to the other side. And then we divide. Well, what happens when we divide? All the 3's cancel, believe it or not. And we get y minus x squared over y squared minus x. Well, we're looking for where the slope is 0, which means that this is 0, which means that y equals x squared. That's what we know about all the points on that curve where the tangent is horizontal. Y equals x squared. So we substitute. And we substitute right into the original equation. Everywhere we see a y, we write x squared. Everywhere we see a y, we write x squared. And this happens to solve. You can confirm algebra on your own, but this does indeed factor, and it gives us two solutions. This one gives us the point 0, 0 as a solution. This one gives us the point cube root of 2 cube root of 4 as a solution, and we imagined that those would be the points anyway, and so we're looking pretty good with that. One more. Let's find all vertical and horizontal tangents to 3x squared plus 4y squared plus 3xy equals 24. Let's find that. All the vertical and horizontal tangents. And we know that there are vertical and horizontal tangents because we can graph this thing, and it looks kind of like an egg. But there are definitely places where there are horizontal tangents, and there are definitely places where there are vertical tangents. So let's do that. Looking for derivatives on the left side. On the left side, that's a 6x, no problem. That's an 8y dy dx, no problem. This is a product rule, but we've done this before. First times derivative second plus second times derivative first, and the derivative of a number is 0. So then what happens? Well, dy dx, these stay on the left side. The 6x and the 3y go to the other side. 8y plus 3x is factored out and divided. So what are we looking for? If we're looking for the horizontal tangents, the horizontal tangents come where dy dx is 0. That means that negative 6x minus 3y is 0, which means that y is negative 2x. And that sort of makes sense. You can imagine the y equals negative 2x line running right through there, hits here, hits over here. So by algebra, I'm not going to show algebra, if y equals negative 2x, we take that negative 2x, we put it here, we take the negative 2x, we put it here, we do some algebra, we get that y is plus or minus the square root of 96 over 13. Very common number, you would have guessed it anyway. If we're looking for the vertical tans, I'll go blue for the sake of good color here. The blue lines happen where dy dx is undefined. Well, what makes a fraction undefined? Its denominator is 0 and its numerator is not. This means that y is negative 3/8 x, and then we do the same algebra. The negative 3/8 x goes here, the negative 3/8 x goes here, and we do some algebra. And after that algebra, this implies that x is plus or minus the square root of 112 over 35. Sorry, that's a 35. So there are two horizontal tangents, they are these lines. There are two vertical tangents, they are these lines. What you should be familiar with is the process, taking derivatives on both sides, collecting dy dx to one side of the equation, factoring, and dividing. Hopefully these have been helpful, and they will give you some tools to use as you go through your practice problems.